So I think we're going to get started. So welcome everyone. The room is still coming in. This is the joint meeting of the Nature Guelph Wildflower Society and the Trees for Woolwich group from Tweak, our joint program of welcome to Speaking of Trees. So welcome tonight on this cold night. I think we're all happy that this is a Zoom presentation. We don't have to go out and drive. I'd like to acknowledge that we are meeting on the ancestral lands of several First Nations. We recognize the significance of the Dish with One Spoon covenant to this land and offer our respect to our First Nation, Métis, and Inuit neighbors as we strive to strengthen our relationships with them. The interesting thing this month was the child welfare settlement, a nearly 15-year-old legal battle over the racist underfunding of federal welfare services on reserves ended with an out-of-court settlement this month. The agreement will spend $20 billion to compensate tens of thousands of families victimized over the last 3 decades, and another roughly $20 billion over the next 5 years on program reform to current child protection services on reserves. This is the largest settlement in Canadian history. I'd like to take a moment to remember John Wismer. John was a lifelong conservationist and nature lover, could identify birds by sight and sound, and he also enjoyed botanizing. He was one of the founders of the Guelph Field Naturalists, now Nature Guelph, and served as the first president in 1966 and 1967. John attended Nature Guelph's meetings until his passing on December 13th, 2021 at the age of 86. Nature Guelph connects people with nature and inspires them to celebrate and protect it. We do this through education and action, our education speaker series, and our action on conservation projects and advocacy. Your membership matters if you're a member of Nature Guelph. We are entirely volunteer run and your membership helps fund these programs. More importantly, every individual member adds a collective voice so that we have a greater impact with our advocacy efforts. If you have not already joined us, you can purchase a 2021-22 membership online at our website or by mail. The other ways to support Nature Guelph are through our general funds, which are available at Canada Helps. If you look for Nature Guelph, and then choose the fund that speaks to you. Tweak, the Township of Woolwich Environmental Enhancement Committee, works together with the township to improve the quality of our environment through environmental projects and education. Trees for Woolwich is an initiative which seeks to increase the canopy cover and has planted over 35,000 trees since 2011. I'd like to welcome members, friends, family, and visitors. This event is free, as they always are, but donations are always welcome. You can donate to Nature Guelph, as I said, through Canada Helps. You can also donate to Trees for Woolwich. You can go to healthywoolwich.org, hit the donate button, and then choose Trees for Woolwich in the reline. And charitable receipts are available. Put a call out for Nature Guelph volunteers. We're always looking for writers and copy editors to assist with our Nature Guelph communications. The Guelph Bird Wing and outdoor events are always looking for people to suggest projects or lead outings. We're trying to hopefully go to hybrid meetings if this virus ever allows us to meet in person. And we are currently looking for a new representative to help with rare sites on their land conservation and acquisition committee. Trees for Woolwich is also looking for volunteers. They need planters for their spring planting dates. They're looking for tree waterers for those who want a fitness workout with a fire hose. Inga tells me it's great fun. There are nursery helpers in their tree nursery to learn how to plant trees and grow them up bigger. You can weed the tall grass prairie, which would be lots of fun. Social media savvy will to spread the news, and everyone has a talent they can use. So if you want to help, but you don't know how, you can contact healthywoolwich.org. So Trees for Woolwich, their activities, they stay tuned for some spring planting dates in May. If you're looking for other things to do, you can watch Nature Guelph's YouTube channel. This program tonight is being recorded and it will be up on that channel shortly. You can share your photos at the Guelph Community Nature Facebook group. And there are some upcoming events for Nature Guelph, including the birdwing people who will be talking about birds on February 3rd, learning about winter birding in Algonquin. The Nature Guelph major series will be The Whisper on the Night Wind. Adam Shoals, who's always a sellout crowd pleaser at our events, is going to return to discuss his brand new book, The Whisper on the Night Wind, True History of a Wilderness Legend. And that's on February 10th. It'll be a Zoom presentation. You have to register for it, the same as you register for this one. And then our next Wildflower Series, again, in partnership with Trees for Woolwich, is Homeowner Action to Protect Water Quality. Becca Robinson from REAP, Healthy Yards Advisors, will be talking about how our rain gardens, trees, and infiltration galleries are important tools to reduce flood risk and treat stormwater runoff. So I'm going to ask you to mute your microphones, turn off your videos, and you can post questions to the chat. We'll answer those later. And I'm going to invite Inga to introduce Gerard Courtin.
Yes, it is my privilege to be able to introduce Dr. Jared Courtin this evening. He has a long and illustrious career, and he's been both a friend and a mentor of mine since he started his academic career at Laurentian University as a professor of botany and ecology way back in 1968. I will try to keep it brief and still do him justice. He was a pioneer, in addition to his teaching, a pioneer in the recreation and reforestation of the Sudbury Basin after extensive environmental damage from mining, lumbering, and fire. He also pioneered the study of plant adaptation in the high Arctic. He has won several distinguished teaching awards for inspiring a whole generation of students about the natural world. Tonight, though, he is speaking to us about his late career shift into the world of forensic botany, using his skills with respect to both plants and soils to become a recognized expert in the Ontario Superior Court in using trace elements of plants and soil as evidence in what is euphemistically known as suspicious deaths. Tonight, CSI comes to your home. Dr. Courtin is a professor emeritus and is now also an adjunct professor in the School of Forensic Science and in the School of the Environment. For 50 years, Jared has excited the curiosity and the intellect of a whole generation of students and a whole generation of community members like myself. And I have no doubt that he will pique your interest this evening in forensic botany. Take it away, Jared.
Thank you, Inga. Wow. Yeah, I don't believe any of that. When Inga asked me to talk with you, and we agreed on a title, it was only after we had decided on forensic science that I got hold of myself and said, "What were you thinking, Courtin?" This is as you'll see, a rather complex pathway. And I'd like to just mention one or two things previously, and that is that when I looked at the registration form, I was a bit concerned that whereas the description is accurate, it may have conjured up that I would be presenting images in connection to homicides. I believe that's unnecessary. I think that I can speak to the discipline without highlighting death in gruesome detail. True, it is there, but those of us who have to confront it have to detach ourselves from the human being who was to the body that now is. Those of us who have to do so because we speak for the dead as they can no longer speak for themselves. It is extremely unpleasant and often very unsettling. I have no intention of going there. Can we share screen? We share screen. Boink. 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 There we go. So perhaps the title that I have chosen says it all. The journey has not been straightforward. As far as careers are concerned, many are like a newly minted loony. Bang, ready to go and be useful to society. You decide to, for some reason, to be a doctor. You specialize in oncology, and you spend your working life as an oncologist. Bang, ready to go and be useful to society. No forensic scientist that I know about was minted a forensic scientist. True, most of us started out with a fundamental university education. But following that, he or she was forged progressively on the anvil of time by an anonymous blacksmith wielding a number of different tools and hammers that might well include choice, opportunity, mentoring, chance, influence, experience, lots of experience, success, failure, and probably pure luck. The implement wrought by the smith may even surprise the smith himself, because even he or she is not quite sure what it is that they have made. But some passerby comes to it and says, that's odd, for sure, but I believe that I have a use for it. Not minted, wrought. So in short, few of us become established in the discipline by design. Rather, you just get rid of this stuff here. Damn. I have a whole bunch of stuff on the sidebar on the right-hand side I need to get rid of. Masking.
If you click on the view and pick speaker view, you won't see everybody else's faces if that's what you're trying to get rid of.
That's what I'm trying to get rid of.
Okay, so if you click on the little view button, which should be up in your upper right-hand corner, maybe. You'll get some view options. Yeah.
No, not in mine. Well, never mind. I'm just, I can't see my entire screen, and that's a new, oh, wait a minute now. Can that get rid of it? No. No. This is frustrating.
Sorry, I believe, sorry, Melinda here jumping in. I believe if you hover your cursor at the bottom of your screen, there should be a bar that appears. It's hidden most of the time. Hover the cursor along the bottom and a bar should pop up.
No.
With various commands.
No.
No, sorry.
No. Maybe if I escape. Sorry for the delay. Good grief. Enter. Does that help? No. No. well, I'm going to have to live with it. That's all. This is not a glitch that we had anticipated. Okay, so I apologize for all of that. I always pride myself on being seamless at presentations, and this is irksome. So just to summarize again, as I say, few forensic scientists become established by design. They fall into it because of years of experience and because they possess a set of skills that lend themselves to the demands of making sense of evidence associated with a suspicious death. I think that's probably as good a summary as I can put to what we do. And finally, there has to be somebody who has knowledge of that particular person's background. My own background, in just a minute, is I was always a rebel. As a forestry student at the University of New Brunswick, I found myself swimming against the current from the start. I was not interested in harvesting lumber. I was not interested in stopping forest fires or preventing insect and other diseases from affecting trees. I was interested in how trees grew, what sorts of habitats they needed, the whole world of in fact, forest ecology. And at the same time, I wanted to know how wood was made up, how trees were made up, and that involved wood technology. I stress that because it becomes important later. At the same time, much to the frustration of my forestry faculty, I started to take courses in science in the science department, and plant ecology and taxonomy and plant anatomy. And I mentioned plant ecology, especially here in bold, because that was the turning point in my career. I stopped really being a forester at that point, and I became a plant ecologist. Forestry has always been in my background, but there was a major fork in the road, and I took it. That led me to graduate studies, and there is some.
Just one. Finally made my way through Dune, but I didn't really enjoy it. I think I read it when I was younger.
Angela, please mute yourself.
Hard to get into.
Okay, I think you can continue on, Jerry.
Thank you. My graduate studies took me to more of the same, but there were two disciplines which have been pivotal to my entire career. One of them being meteorology and climatology, and the other one glacial geomorphology. And those came about as necessary because of my thesis research. And let me stress that it was not the destination, but the journey that has been so important in my teaching of students over the last 50 years. The plant ecologist today, or at least just before Christmas, turned 90. She remains a friend, now lives in Ottawa. Patricia Roberts was the one who lit my fire with regard to plant ecology, and I owe her more than she will ever know. So where do I work? Well, this could be a perfect venue for a juicy homicide, a cabin nestled in the woods with meadows in front, all kinds of possibility for nefarious dealings, and then maybe hiding the body somewhere. Many of you are horticulturalists and master gardeners, and this is probably more the sort of thing that you enjoy. It's certain that somebody might drag a body through that herbaceous border, but it wouldn't be the vegetation that you see that would be important. It's what you don't see. And my palette is this sort of thing. The dead material that most often is on the ground and the soil that's associated with it. So you have to ask, well, where did all this start? And believe it or not, it started with a paper grocery bag full of bones. And little did I know that that bag of bones would change my life, or that it would launch me into a second career just as I was on the cusp of retirement. And certainly I could not at that moment have realized in my wildest imagination that one day I would be testifying in court, in giving information to a jury who had been jurors for 5 horrible weeks of gruesome testimony, and that I would be trying patiently to explain to them how the forest communities in the eastern deciduous forest that extends all the way from Georgia to Tomogamy were distributed, and doing so by using the analogy of a bag of M&Ms. But that's the sort of life that I have led. So this bag of bones came to me through a telephone call. And my colleague in anthropology, who knew I had an interest in what he did, said, I just received a bag of bones and they've got stuff on them. And that stuff is, I think, the sort of stuff that you're interested in. I wonder if just out of curiosity, whether you'd like to see what I've got. So I said, sure. So I went down and sure enough, we had some bones. And other than the bones then, the questions were, well, what material has become lodged in the crevices and depressions in the bones, which they always do? What is growing on or with the bones? And then there was mineral material, and there was organic plant material, and there was live plant material. So I asked Scott Fairgrieve, what do you want to know? Well, does it tell you anything? I said, sure. It was a shallow burial. I noticed that the sand is most likely outwash sand. You tell me that somebody just happened by and saw bones. And so that rather indicates to me that there's been erosion. Well, where would that occur? That would probably occur along a lake shoreline, or possibly the shoreline of a stream, or maybe a borrow pit that's being used for building a new bush road. Really, yeah, and it was in a stand of balsam fir. Okay. Let me ask you this. Could that be those remains? Could they be the remains of a homicide 16 years ago? Not a chance, I said. Those bones have been there at least 80 to 100 years, probably more. Really? Yes. And you're sure of that? Yes. So that weekend, he and an assistant went up to the site, which he had not seen, and I certainly had not seen. And when he returned on the Monday, I got a phone call, and Scott says to me, well, the biggest compliment I can pay you is that when we got to the site, I turned to my assistant and I said, well, the old SOB was absolutely right on the money. And the important thing of that exchange was really that an anthropologist working mainly with bones and a specialist in cremated remains saw some value in a botanist who'd had nothing to do with forensic science. And I, in turn, of course, said, well, maybe I can be useful. And that's where it all started, just almost by pure chance. Now, I mentioned that I was certain about the shallow burial and the how long it had been buried there undisturbed. In southern Ontario, you probably never see soils that have been undisturbed, unless you are in a relic forest somewhere, which they probably don't appreciate you digging holes in. But this is a perfectly normal northern Ontario soil. That gray zone is the top of the mineral layer, overtopped by organic matter. And the process here is called podzolization. A podzol, this is from the Russian, a pod meaning ash, and sol, obviously soil. So these are ashy soils because of the color. What happens here is that with rain and snow and decomposition, acids, fulvic and humic acids are liberated as the organic layer decomposes, and those acids are leached down through the soil, removing the colored material, which is normally iron and aluminum and manganese. And it is deposited then further down the profile. But that podzol layer, that ashy layer, always is the top layer. And if the gray mineral material on the skull was an indication, then it was a shallow burial. I found out later this was a native, a young woman who knows how she died, but the band in that part of the world always buried their dead in shallow graves in remote areas, and this was a small island in the middle of a lake. And one of the things that I've learned is that you always expect the unexpected. Yes, everybody is as dead as the next one, but you're always looking for something that doesn't quite ring true. And especially for me, of course, in a botanical and ecological context. Too many people, when they are studying homicides, are focused, of course, on the body. What else? For me to be useful, I need to be looking probably almost everywhere but the body. So again, Scott phones me and says, I've got a body. Can you come down and have a look at it? I said, sure. And turned out to be an individual who died in a snowmobile suit. Obviously some considerable length of time prior to its being found. The body and the suit were pretty much fossilized. But there was one thing that there were a couple of things I noticed. I said, well, this person died in a thicket of black spruce. What makes you think that? I said, there is nothing but black spruce needles all over that snowmobile suit. And what about this branch? The one with the arrow there. I said, well, the people that were recovering the remains said that it was growing around the body and suggested that it ought to come with the body. I asked Scott if I could have it. And he said, sure, I don't want it. I'm a bones man. So I said, fine. Now, you need to know something about the way black spruce grows. Black spruce is the only conifer, at least in our part of the world, that layers like a strawberry plant, i.e. the branches, the lower branches sweep down to the ground and become rooted. And it seems that this individual died and fell on a shoot, and that shoot was simply bent and horizontal with the ground. But plants like to grow vertically, and so the plant in its next growing season began the process of going from horizontal to vertical, and that takes time. And I cut the branch that I'd been given right at the inflection point where it turned the body, and then looked at the rings that were produced. And not surprisingly, as the growth continued, so that the plant could go from horizontal to vertical, it packed on more wood on the outside than it did on the inside. And so that was logical, but really didn't tell me very much. I looked at the distribution of widths of rings, either enough to measure across a diameter, and I got this sort of image, and it really didn't tell me very much. But I figured that there had to be something there that I could use. And so I thought, well, what if I take a diameter right through the middle of the disc, and if I measure the width of a ring on the one side of the center, and then follow it around and measure the same ring on the other side and its width, and subtract one from the other, and to do that for every ring, what would I get? And what I got was something that was easy to interpret and very useful. The body was found in 1999. And what we see here is that the first positive change in ring width occurs after the winter of 1990. And so we see the effect of rings being built up on the outside of the twig, and until it's once again vertical, and then so it doesn't have to expend unnecessary energy. The decrease in ring width progressively on that side until both sides of the center are have the same, roughly the same diameter. All I had to do then was to go back in time to 1990, and I have the analysis in words here. The type of clothing worn, i.e. the snowmobile suit, indicated that death occurred in fall or winter. The body fell across a black spruce branch, such that it was bent into a horizontal plane rather than growing vertically as before. And the following growing season, the branch laid down reaction wood as it's attempted to resume vertical growth. There were 9 years of growth since, and including the first year of eccentric growth, indicating the time of decease. Body was found in 1999. Death was suggested as having occurred in the fall of 1990 or the winter of 1991, and that was my suggestion because of the snowmobile suit. But in fact, the death was a suicide, and it occurred in August of 1990. So I had the year right. I was out by somewhere around 3 to 4 months. It was a valuable lesson, and in order for others to get to know about this, we published our findings. But the stuff that I've described to you so far is the easy stuff. Now we need to look at some of the real challenges. In terms of evidence, I suppose it seems reasonable, but not necessarily true, as you'll see, that the crime scene would have to have some association with the outdoors for plants or so to have a bearing on the case. Botanical materials, soils, evidence that is likely to be picked up at the scene could be associated with clothing, with shoes, with boots, a vehicle. In fact, anything that would or could move from the scene of the crime. So a few examples of the trace evidence that was mentioned in your registration. The top left here is a victim's T-shirt. That is the front of the T-shirt. It's covered with organic matter. One presumes that it was dragged, and it was dragged face down. And that poses a challenge. The material in the top right, to give you an idea of scale, the top part of this is a different color to the bottom. This is the sticky part of a Post-it note. And the police officers who seized the information decided that that was the best way to preserve it, and it certainly was. But that is material that is not more than somewhere around 3 to maybe 10 millimeters in height. And the one on the right-hand side has been enlarged here, and it looks like sort of gravel or anything. This is material that is particle board. It's made up of sawdust. This is brutal stuff to work with. Inga mentioned CSI. Well, the real CSI is this sort of stuff. None of the work that we do is solved in 1 hour. And there is nothing particularly exciting or even dramatic about it. It's just hard grinding work. This particular case I worked on and off for 18 months before having to come to the conclusion that the debris found on the bed sheet in which the body was wrapped did not have any connection with the four possible sources of this material. A very unsatisfactory ending for everybody. Bottom left, a shoe. Any shoes that have any tread to them are likely to be candidates for picking up material from the ground, from mud, and they frequently have have pollen associated with them, or other debris, but pollen especially. And then the bottom right, and I will come back to this, that's just seed material, but it has a story. So not surprisingly, almost anything in terms of plant and soil is fair game. Twigs or branches can be especially useful because you can identify them to species. Bark, a little bit more difficult, but you can often do something with that. Leaf or leaf fragments, we'll come back to them in a moment. Pollen and spores, again. Bud scales, different species have bud scales that are identifiable as being different. Flowers or flower fragments obviously can be there, but flowers have a very short life, and once they are faded and wilted, are very hard to work with. Seeds or seed fragments, we'll see again. Moss or lichen fragments, I pass on to a moss or lichen specialist. I don't profess to be able to do much with them. And then organic matter and mineral soil, and we've already seen some evidence of that with the case of the grocery bag of bones. But just as in almost every discipline where there is a need for knowledge of various kinds, it is important to know how how you have to know the terminology to describe what you're seeing. All of this, you are all botanists or involved with trees. This is nothing new to you. But you can recognize the lobes of a red oak, the teeth on a birch, the fact that the margin of a red osier dogwood is completely smooth, the compound leaves of a rose, a simple leaf of a willow, and then the venation, which can be either palmate, such as in a sugar maple in this case, or pinnate, as in the case of a hawthorn. That is what we know as botanists. That's part of our general training. When it comes to forensic analysis, however, you would of course love to have a leaf like this, already somewhat decomposed but quite recognizable, but you're far more likely to get something like this, a fragment. The rose again, you get a leaflet. Is it actually a leaf, or is it the leaflet of a compound leaf? These are the challenges which one faces all the time. And now I need to think about the fact that leaf fragments can tell you a lot, because there are a lot of things that one can look at. Venation being one of them. Some leaves have hairs or pubescence. They all have stomata, but those stomata can look very different. They all have margins, and the margins, as we've already seen, can be different, and so can the lobes. This is important from the point of view of testifying in court. If I'm working for the prosecution, they automatically assume that I know what I'm talking about. The defense, however, it's incumbent upon the defense to make absolutely certain that I do know what I'm talking about, and they will try and discredit my testimony with some searching questions, and that's fair game. I like to be ready for them, by knowing as much about the fragment as I can. Not that it's such and such a species, but to know a lot more about it. Now, if we take a look at 7 species here, you're probably familiar with almost all of them, maybe all of them. And you don't have to be a rocket scientist to recognize that the veins on these plants are all different. The question then becomes, well, yes, they're different, but can you describe them? And I have to give credit to one of my sons, who I think purely by chance came across on the internet, came across the Manual of Leaf Architecture from the Smithsonian Institution. And that manual describes, by giving names to various characteristics of leaves, which have been absolutely invaluable to my work. A photograph, or at least a drawing of 4 different sets of stomata from different species. And all one has to recognize there is that different species have different shaped stomata embedded in the epidermis differently, but all characteristic. And on the right-hand side, then a couple of photographs, compound microscope photographs of stomata and their epidermis. The other characters, one of the other characteristics is that of hairs or other ornaments on leaves. And so a vine of the common hop has glandular trichomes, very, very rough. This is the back of a geranium leaf, a pelargonium. Silky trichomes along the vein, very characteristic. And then 3 species of willow, all of them different species, but the pubescence or hairiness varies from one species to another. These are all characteristics, can be very, very important. So that's the practical knowledge, what I call the toolkit. Now for the application. A homicide in southern Ontario. And this is typical of material that I might receive. Some twigs and leaves from a plant, and then 3 separate leaves from various places. If we look at the plant, first of all, it is Ficus Benjamina, which is a commonly used houseplant because it's subtropical, and because it's subtropical, it tends to like warmth, and it can tolerate a certain amount of misuse, mistreatment from watering, and so they do fairly well indoors. 3 leaves, the leaf in a victim's underwear. I have absolutely no idea how it got there. I have never asked. I have never been told. It doesn't matter. There was a leaf frozen into the driveway. Interesting. There was a leaf in a dwelling close by. They are all fig leaves. They all have the same characteristics, the same pattern of veining, and they have another characteristic, which is one which is not unique, but generally very important in fig trees, and that is what are known as Pelucid Dots. There are in the upper epidermis, or below the upper epidermis, there are places where there's no chlorophyll. And so you get these little clear dots, which are very, very easy to see. And all of those leaves have it, as well as the parent plant. So the question then is, are the leaves found in the 3 separate places consistent with those of the houseplant? Notice the word consistent. I'm not saying it's the same, I'm just saying consistent. And the answer is yes. But the defense is going to say, why do you say that? They're just leaves. Well, because the vein pattern is the same, they have pellucid dots, the stomatal size, distribution, and density are the same, and figs are subtropical and cannot grow outside in our region. So the one that was frozen in the driveway certainly didn't come from a fig that was growing in nearby. The testimony in court then is, and Canadian law always favors the plaintiff. I cannot say that the leaves are of the same species as the houseplant, although I know that they are. I just fail to exclude that the leaves are of the same species as the houseplant. It sounds backwards, but it is the way it's done. I also fail to exclude that the leaves are from that particular houseplant. But I certainly exclude the leaf on the driveway as having come from a tree growing outside. And that is the sum total of what I am able to say. And one of the things that I learned very early on, that in court, in Canadian court, you either know or you don't know. You never surmise, you never think that. It's either you know or you don't know. And it helps to be able to use that term, I fail to exclude, and we leave the jury to connect the dots. I mentioned mud on the soles of shoes. We have chemical techniques which allow us to separate out pollen grains from soil. It looks a bit of a dog's breakfast on the left-hand side here, and the pollen grains have been stained with a vital stain, which makes them easier to see. But the only message here is that the various pollens that you're seeing here are all different one from the other, and they all are characteristic, and they all come from different species. This can be useful. And there is a lot of power to pollen work. And I'm going to allow somebody else to talk to us for 7 minutes. And I think it's a little video, it's a TED Talk that you will find perhaps entertaining, but also informative.
I've got 2 missions here today. The first is to tell you something about pollen, I hope, to convince you that it's more than just something that gets up your nose. Secondly, to convince you that every home really ought to have a scanning electron microscope. Pollen is a flower's way of making more flowers. It carries male sex cells from one flower to another. This gives us genetic diversity, or at least it gives the plants genetic diversity. And it's really rather better not to mate with yourself. That's probably true of humans as well, mostly. Pollen is produced by the anthers of flowers. Each anther can carry up to 100,000 grains of pollen. So it's quite prolific stuff. And it isn't just bright flowers that have pollen, it's also trees and grasses. And remember that all our cereal crops are grasses as well. Here's a scanning electron micrograph of a grain of pollen. The little hole in the middle we'll come to a bit later, but that's for the pollen tube to come out later on, very tiny tube. So that's 20 micrometers across, that pollen grain there. That's about a 50th of a millimeter. But not all pollen is quite so simple looking. This is Morena. This is a plant which I've always thought to be rather tedious, named after Morin, who was an enterprising French gardener who issued the first seed catalogue actually in 1621. But anyway, take a look at its pollen. This is amazing, I think. That little hole in the middle there is the pollen tube. And when the pollen finds its special female spot in another Morena flower, just on the right species, what happens? Like I said, pollen carries the male sex cells. Perhaps you didn't realize that plants have sex. They have rampant, promiscuous, and really quite interesting and curious sex, really a lot. My story is actually not about plant propagation, but about pollen itself. So what are pollen's properties, I hear you ask? First of all, pollen is tiny. Yes, we know that. It's also very biologically active, as anyone with hay fever will understand. Now, pollen from plants which are wind dispersed, like trees and grasses and so on, tend to cause the most hay fever. And the reason for that is they've got to chuck out masses and masses of pollen to have any chance of the pollen reaching another plant of the same species. Here are some examples. They're very smooth if you look at them, of tree pollen that is meant to be carried by the wind. Again, this time sycamore, wind dispersed. So trees, very boring flowers, not really trying to attract insects. Cool pollen there. This one I particularly like. This is the Monterey Pine, which has little air sacs to make the pollen carry even further. Remember, that thing is just about 30 micrometers across. Now, much more efficient if you can get insects to do your bidding. This is a bee's leg with the pollen glommed onto it from a mallow plant. And this is the outrageous and beautiful flower of the mangrove palm, very showy to attract lots of insects to do its bidding. The pollen has little barbs on it, if we look. Now, those little barbs obviously stick to the insects well, but there's something else that we can tell from this photograph, and that is that you might be able to see a fracture line across what would be the equator of this if it was the Earth. That tells me that it's actually been fossilized, this pollen, and I'm rather proud to say that this was found just near London, and that 55 million years ago, London was full of mangroves. Isn't that cool? Okay, so this is another species evolved to be dispersed by insects. You can tell that from the little barbs on there. All these pictures were taken with a scanning electron microscope, actually in the lab at Kew Laboratories. No coincidence that these were taken by Rob Kessler, who's an artist. And I think it's someone with a design and artistic eye like him has managed to bring out the best in pollen. Now, all this diversity means that actually you can look at a pollen grain and tell what species it came from. And that's actually quite handy if you maybe have a sample and you want to see where it came from. So different species of plants grow in different places, and some pollen carries further than others. So if you have a pollen sample, then in principle, you should be able to tell where that sample came from. And this is where it gets interesting for forensics. Pollen is tiny, it gets onto things and it sticks to them. So not only does each type of pollen look different, but each habitat has a different combination of plants, a different pollen signature, if you like, or a different pollen fingerprint. By looking at the proportions and combinations of different kinds of pollen in a sample, you can tell very precisely where it came from. This is some pollen embedded in a cotton shirt, similar to the one that I'm wearing now. Now, much of the pollen will still be there after repeated washings. Where has it been? 4 very different habitats might look similar, but they've got very different pollen signatures. Actually, this one's particularly easy. These were all taken in different countries. But pollen forensics can be very subtle. It's being used now to track where counterfeit drugs have been made, where banknotes have come from, to look at the provenance of antiques and see that they really did come from the place that the seller said they did. And murder suspects have been tracked using their clothing, certainly in the UK, to within an area that is small enough that you can send in tracker dogs to find the murder victim. So you can tell from a piece of clothing to within about a kilometre or so where that piece of clothing has been recently, and then send in dogs. And finally, and in a rather grisly way, the Bosnia war crimes. Some of the people brought to trial were brought to trial because of the evidence from Pollen, which showed that bodies had been buried, exhumed, and then reburied somewhere else. I hope I've opened your eyes, if you excuse the visual pun, to some of Pollen's secrets. This is horse chestnut. There's an invisible beauty all around us, each grain with a story to tell, each of us, in fact, with a story to tell from the pollen fingerprint that's upon us. Thank you to the colleagues at Kew, and thank you to palynologists everywhere.
So back to that fleece vest. And most of the audience, I strongly suspect, are old enough that they probably have a partner of some sort. Most of the time when I'm lecturing to students, I can assume that if they're married, they certainly aren't churched. And but the scenario that I want to lay on you here is that this is my shirt. I collected that debris on my shirt, and then I went into the house where my wife took one look at me and said, "Where have you been?" And I innocently said, "Well, I just took the compost out at the bottom of the garden." "Well, look at you." "Yeah." "Oh, well, yeah, I guess I've got stuff on me." "Well, not only that, but now I know you're just going to go upstairs and you're going to sit in your comfortable chair in the living room, and all that fluffy stuff is going to finish up on the chair." And of course, I made a fundamental mistake there because the penny had dropped, and I said, "Oh, yeah." And that was not the thing to say. But it was the thing to say, because that little episode made me realize that there was elements of vegetation that could transfer themselves, that would stick well, just like pollen, to clothing, and that would transfer from one place to another. There's just a close-up of the same garment. And the ones that you are most probably conversant with in terms of what we in our lab call fluffy stuff is the flowering head, seed head of a dandelion. And but my thinking began to go further right away. It's lots of plants, especially plants in the daisy family, have got exactly the same sorts of things. They've got seeds with this hairy plume on top that allows them to either stick to things or get blown around. But I'm thinking immediately of where they grow, and they grow along roadsides quite commonly. And a roadside is a perfect place for if we imagine a half-ton truck to pull up to the edge of the woods here, pull out a corpse, and then drag it into the bush, taking along with it some of this material. Now, very often, because a body is an embarrassment to the person who has made it that way, it gets moved. And so it is quite possible that that same person would come back at a later time and move the body elsewhere and maybe bury it. But where it went into the woods is going to have a signature on it because of the sorts of plants that it picked up on the way in. I was fortunate at the time that all this happened to have a very talented student who was looking for a thesis topic. And knowing that this was a young lady who would never stop until she was satisfied, was a perfect person to choose. And so she worked on this problem, and that is the title of her thesis, The Characterization of Cypsela pappus units in the Asteraceae being the daisy family. And the Cypsela is the seed, and the pappus is that fluffy thing on top. And so here is a typical example. This is Joe pieweed, which is exactly the one that I had rubbed up against when I was at the compost heap. This you probably all recognize as goldenrod, and there are a whole bunch of other daisy-like plants that you are probably very familiar with. So the mission was that I set Louise was locate all the members of the daisy family growing at roadside in our area around the campus. Collect them in flower and make voucher specimens, like voucher specimens, so that we know exactly what we're looking at in terms of the species. Note the start and the end of the flowering for each species, because that could be important forensically. Note the time of seed set, and then collect seeds, the Cypsela and the hairy tops, the pappus. And then your mission is to identify each species on the basis solely of their Cypsela and their pappus. And so Louise set about doing this and said, okay, well, the thing that I see that is constant is the shape. The shape is either elliptical, or it's obovate, or it's oblong. And if we just take a look at one of her exercises or her sampling techniques, she looked at an elliptical Cypsela. She determined that they could either be elliptical, but that they could be lunate, i.e. Sort of narrowly moon-shaped, or that they were just completely straight. And that the only ones that had lunate elliptical Cypselas were Lactuca canadensis, which is wild lettuce. But the the ones that were not lunate could either be rough on the outside, rugulos, or smooth. And the ones that were rugulos was one species of Sonchus, sow thistle, and the ones that were not rugulos with another. So on the basis of just the Cypsela and what it looked like, able to separate two very closely related species. And she did that for all the other shapes as well. And then she looked at the pappus and determined that there were essentially three morphologies to the pappus, that it was either just almost like a ball with hairs coming out all over the place, or that they looked like a parachute, which was the one that we are so familiar with a dandelion, and then ones that look like a cone upside down, an obconic cone. And so again, as just an example for us tonight, the parachute. And now she looked under compound microscope. She was looking at the individual hairs, and she looking at the individual hairs, she came to the conclusion that there were three typical arrangements. Either that they had little ornaments on them that were moniliform, i.e. that they were like a string of beads, or that they were feathery, or that they were toothed. And on the basis of those three morphologies, she came up with, again, one of the sow thistles, that was a mistake, or goat's beard, or again our friend dandelion. And as a tribute to Louise, for whom I have tremendous respect, this was from her own thesis and her own presentation. And I think that probably anybody who's more than 20 years old does not need to be told what the source of that particular image is. I'm probably over time, but I already spoke briefly with Inga, and she cavalierly said that nobody's got anywhere to go tonight other than maybe to cozy up to a glass of wine, so go for it. So I am going to go for it, and I'm going to go for it because I think that the last case here is an important one to understand just where we are in terms of the evolution of forensic science. In every case that one investigates, you answer a question, obviously, but it always leads to another question. And so in this particular case, this was, again, of course, a homicide. And according to the police, they found a 1.5 meter long section of a birch sapling with blood on it. And the victim had obviously been bludgeoned to death. But the question was, could one link the weapon to the victim? They seized at autopsy slivers of wood that were embedded in the flesh. And the question then was, well, is there a linkage? And here, I was extremely grateful for some of my early training in wood technology, because I had learned some 50 years back how to macerate wood, to dissolve wood chemically into its individual fibers, into its individual cells. And so one is able to look at the composition of the wood, and especially the vessel elements, this large, in comparison to the rest, this large a tube, essentially, which is the water carrying element in a piece of wood, in a tree. And in this particular case, what's to notice here is what is known as the perforation plate. This is the part of the cell, because it's a tube, which is joined to the next cell. And of course, they've been separated. And the perforation plate in the case of birch is a scalariform, a ladder-like perforation plate. And because of that, and some of the other ornamentation here, and its size and its length, it was obvious that it was birch. So yes, there was a linkage. I could not exclude that the fragments of wood that had been taken from the embedded in the flesh, I could not exclude that they had as their source the alleged murder weapon. But at the same time, that also asked the question, can we in some way link the murder weapon to the site of the homicide? It was a birch, we've just established that. But was it consistent with the base of a birch still rooted in the ground? And in fact, the police also seized that portion of the birch. But the fracture between the murder weapon, or the alleged murder weapon, and the part that was rooted in the ground, was ragged. And so it was impossible to suggest correspondence in such a way as to have the testimony hold up in court. So the question was then, is there any way we can do that? And the police quite soundly would not let me play with their murder weapon or the alleged murder weapon. So I had to go and create my own. I needed a day when the temperature was -20, which is what the temperature was at the time of the homicide. And I knew it was white birch, and I had plenty of those around me. So I made myself a murder weapon. And then I did the same for a couple of other trees. And the reason for that is that I needed to be able to link the murder weapon with the stump, but I wanted to make sure that I was sufficiently satisfied that one was joined to the other by comparing it with ones that were not, i.e. there were stumps, but I could determine possibly that those stumps did not match the murder weapon. And the question then was, well, how are we going to do that? And it was a question of, again, of thinking outside the box. And I've often said that my work, I never reinvent the wheel. I just use my training and my knowledge, and I simply put new tires on it. So what I did is I cut and polished the disc of the wood above the zone of fracture. I cut and polished the disc of the wood below the zone of fracture. And then I measured the width of the rings on both discs and on four radii to give myself a mean. And then I regressed one set of measurements against the other. So there are my discs, measurements in this direction, same with both. And then I took the data and I plotted them. Upper ring widths versus lower ring widths. And I get a regression coefficient of 95.95, which is simply says in layman's terms, I am 95% certain that the disc above the break is consistent with the ring below the break. They come from the same source, the same branch, the same stem. And when I did that with murder weapon, the upper disc versus a lower disc from one of the other stumps, I got answers of 17% and 23%. Quite clearly, this was I had so shown to my satisfaction that this was a technique which had merit and which would probably hold up in court. And to make sure of that, we published it. So now we can in court, when we testify, we can say we've already done this work and probably get it accepted. So there you go. The end of my journey. The one thing that I wanted to leave you with, however, is a marvelous read for anybody who has an interest in a real live forensic ecologist, as I possibly can call myself, but certainly Patricia Wiltshire is the dean of forensic ecologists, an amazing woman with an amazing life, not all of it very easy, who started out just as I did, a long way from forensic science. She was an anthropological palynologist. Her work was to look at sites that were being excavated to determine, or looking at remains from 3,000 years or so ago, and looking at the distribution of pollen at various depths in the dig, and being able to recreate the vegetation of the time. An incredible skill, and she was a specialist when it came to pollen. And there came a day for her, just as there was a day for me, when somebody recognized that she might have the skills to determine some evidence that no other technique would allow. And that started her career, and she's recently retired, but the book is a wonderful read. I recommend it to anybody. The Nature of Life and Death by Patricia Wiltshire. Any questions? There is silence, so everybody's asleep.
No, there is one question that's been posed to Jared, which is that as we are now barcoding the world, will DNA make it easier to identify species and correspondence?
I think correspondence, and I'm thinking of a case which I had the knowledge at the time, I could have solved. This was a simple case of theft of Christmas trees, and it was the police had taken a disc from the base of the Christmas tree, and they had taken a disc from the stump. And at that time, I didn't have the wit to realize that I could do what I've just described to you. But now the question is the DNA of one disc and the other disc, could you determine correspondence? Yes. I don't think that you need to know the whole DNA sequence to species. You don't need to know what the species is to establish correspondence where you are fairly certain that you're looking at the same two sources. Barcoding, I'm sure, I know nothing about it other than the fact that it's obviously a very powerful tool in this world of DNA. I don't profess to have any knowledge of DNA. I immediately, if that comes my way, I pass it to one of my colleagues in the department. The one thing that one has to recognize, however, is that DNA, human DNA, is easy. We're all the same species. Everybody, the world around is all the same species. So we have all the markers for human DNA. But that first shot that I showed you of a cabin in the woods, I suspect that you were looking in vascular plants alone. You were probably looking at somewhere between 50 and 100 species. And each one of those is going to have its own markers. So it's not as easy a business, although there are people who are doing a lot of work with plant DNA. And again, I am not conversant with that. It's just beyond my abilities. My skill set is elsewhere.
Thank you. The other question that has popped up from Maria is, how did you learn all of the information that you have about plants? Was it college classes, or was it outside research like books? My guess is that it was a lot of time spent in the out of doors, but I'll let you answer.
You're of course right. If I can be anecdotal for a moment, in second year forestry, we all had to take a course called dendrology. And dendrology was simply identification of trees, woody plants, trees and shrubs, both with leaves and without leaves. So we did winter botany as well as summer botany. And in every class, there was somebody who specialized in knowing their species. And in my year, it happened to be me. So anything that anybody wanted to know, any of my classmates needed to know, they would simply throw this twig at me and say, Coutin, what is it? And I like to be right. So I very, very quickly became very, very proficient at the entire woody flora for the area around Fredericton, New Brunswick. The book that taught me all of that still in its original form, I purchased that in 1958, is a book that I could not be without. Although the species names have changed a little bit, by and large, it is a marvelous resource for Eastern North America. So that's part of the answer. The other is, as you said, Inga, experience outside. I spent some time in the high Arctic, and it fell to me in a very, very large project to be the one who was responsible for making sure that we had herbarium specimens, voucher specimens of every vascular plant on the tundra. Now, fortunately, as you go further and further north in our hemisphere, the number of species decreases. The tropics, you have maybe 100 species per hectare. In the Arctic, you probably have 5 species per hectare. So it was an easy task, but I think, if I recall rightly, and it's been many, many years, I think we had 85 vascular species, and we had voucher specimens for all of those. So, of course, my knowledge of the tundra flora was easily acquired. And the other thing is that I had worked for my PhD, I had worked in the alpine zone, and the alpine tundra and the Arctic tundra have a lot of similarities. So it was a relatively easy thing to adapt from one to the other. And what species I didn't know, I very quickly found by using resources at that time, books. I mean, today, I find students, anytime that they are not quite certain of a particular species, but they are, for instance, they might be trying to key out an ash. And then we have 3 ashes in our area, you have 4 or 5 in yours. They would immediately just pull out their phone, and in a moment that they would have all the images of all the ashes, and they could confirm what they thought. In my day, you went and keyed it out. I bemoan the fact that people don't key things out the way we used to, but on the other hand, we live in a different world, and I've come to accept that. I'm not sure if that answers the question for Maria.
Thanks, Jared. One of the other questions, which I think you alluded to at the beginning of your talk, was how you fell into the field of forensic botany. I think you alluded to the bag of bones that was brought to you.
Well, that is the reality, Inga. That is exactly how it happened. That's exactly how it happened. I mentioned at the top of that slide, it was the slaughter of the innocent. I had no idea what I was getting myself into. I certainly never thought that it would be another career, or that I would do, and you appreciate this more probably than anybody else in this. There are other lawyers in the audience. And there is a lot of tension in the courtroom. There is a lot hanging, and in terms of my work, this was always homicide. So somebody was looking to spend most frequently 25 years behind bars without any chance of parole. And I have helped put several people behind bars in that way. You don't take this lightly at all, at all. And the one thing that I had to my advantage was being a teacher, because in essence, you are not talking to the prosecution, you're not talking to the defense, you're educating the jury. And the jury, unless things have changed, are usually people who don't have a stack of degrees. In fact, they are usually shunted out of there as being too knowledgeable, perhaps, because they have other knowledge outside of the case in question. The average juror doesn't, and so they have to work with what they're given. And I have found it very, very important to be completely clear, as clear as I could be with the jury. So yeah, that's how I fell into it. And the other thing, and I mentioned this in my preamble, you are speaking for the dead, and that is a tremendous responsibility. One of the first cases that I had was, in fact, a homicide in which I was given all possible details by the police officer who knew of me because I had done some teaching at the Ontario Police College, and he wanted to know if I would take the evidence for this particular case. And in order to do that, he had to give me the details of the scene. And it was horrific. And this man got hold of me at 10:30 at night and laid it all on me for about 15 minutes. And I said, yes, I will. And then I went to bed. And because I have a vivid imagination, and I have two things which really I cannot stand above all other things, is abuse of women and children. And this woman had been abused beyond belief. I was raging. And raging, I was just a mess. And finally, around 2 o'clock in the morning, I managed to get a grip and said to myself, if you're going to help this woman, because she can no longer speak for herself, then you're going to have to make that transition from the body that you imagine as a living person to the body that is just something, an object on the ground. That is a very, very difficult mental leap, I can assure you. But you either do it or you get out of town. You have no choice. Either you do it or you simply say, no, I can't do this, and you back away.
I'm going to thank you very much, Gerard. It's a very interesting talk. I don't think we've had this talk before. I'm with you. I like to sit down and key out things, but you've inspired me to take more looks at vein patterns, and maybe I'm going to break out my microscope and start taking a look at pollen grains too. And I'm definitely going to try and ID some of those asters by their pappus and their seeds, because they're so hard to tell apart when I'm cleaning seeds and I accidentally forget to label what my seeds are. So I'll have to get a hold of your book.
It's online. That's you, Judy, talking, isn't it?
Yeah, that's right.
Yeah. It's online.
Okay, well, I'll look for that.
It's a piece of cake. I'm not sure whether I can lay my hands on it immediately.
Yeah, I'll take a look, because I've got the recording, so I've got her name. So thank you very much. We're getting very nice compliments in the chat for you. I'm going to remind everyone that's left that if you want to share this with a friend, the recording will be up on the Nature Guelph YouTube channel within the week. And thanks a lot. Now, I'm also going to mention that Jared has very generously declined to take his honorarium for this talk, and instead has donated it to Trees for Woolwich. And that's going to plant quite a number of trees, or it'll be a big start on their tall grass prairie. So thanks an awful lot, Gerard. And if you want a copy of this recording, I'll send you a link of that too, because you were saying you might want it for your family.
Yes, that would be very nice. Very nice.
So once that's up, I'll send you the link.
And one last word: there are 2 monographs for Ontario. One for the goldenrods, and the other for the especially the daisies. So I don't think I can lay my hands on the monographs right this minute, but I'll try and find them, and I'll shunt that down the electronic highway to you.
Okay. Well, thanks a lot. So if I see mostly praise going down in the chat, no more questions. So I'll allow you all to go home and have a glass of wine or a drink of scotch or whatever it is like to do for a nightcap. So thanks so much again. And then I'll remind you, next month we'll be learning how we can all help protect the planet and our waterways by managing water in our gardens. So thanks again, and bye-bye all.
Bye-bye all.